Okay, so the point of doing linear regression ultimately is that once you've found the line of best fit, you can use it to make predictions. But there are complications, let's say, involved in this that we need to be aware of. So this is still the cricket data, the same example all the way through. X is the number of cricket chirps in a 15-second interval. Y is the temperature in degrees Fahrenheit. Let's now use our line of best fit that we found to do an example. In fact, let's do 2 examples. Example: if you count 29 cricket chirps in a 15-second interval, what is the temperature? So this is now plug and play. I mean, X is the number of cricket chirps. So X equals 29 here. And now we have a formula. We can stick that 29 into. So let's go to our, where is my calculator? Give me just a second. There we are. Let's go to our calculator real quick. And it's already on. 1.143 times 29 plus 30.281. Enter. Let me jot this down before we go back to the document camera. So if we think that if we count 29 cricket chirps, it should be about 63 degrees Fahrenheit. Example 2. Let's say you count no cricket chirps. That is to say, X equals 0. Well, we can use this line of best fit to try to approximate the temperature. And we calculate that if we count 0 cricket chirps, it should be about 30 degrees out. Sorry. Unfortunately, this is completely wrong. It just is. The reality is that crickets just stop chirping altogether when it's below about 50 degrees. So counting 0 cricket chirps tells you it's less than 50 degrees out. It does not tell you that it's 30 degrees exactly. What went wrong here? This is the difference between interpolation and extrapolation. So in the last page, we made 2 predictions, let's say. We predicted the temperature if we count 29 chirps, and we predicted the temperature if we count 0 chirps. Interpolation is what we call it. If the x value we are interested in is between known values. So going back to this, we're interested in what happens when we count 29 cricket chirps. Let me get our data set up here. 29. So we have a value for 20, and we have a value for 18.5. That is when we, hold on, what am I? What is this data set? How the heck can you count 20.4 cricket chirps? Okay, I am not redoing all of these videos. There's obviously some kind of typo here, but we're just going to let it ride. Anyway, the value we're interested in, 29, is between 20.4, which is a known value, and 31, which is a known value. So the value we're interested in is between 2 known values. On the other hand, the other value we asked about, which was 0, is not between 2 known values. If you go back to this data set, the lowest value we have data for is 18.5. Zero's way outside of this data range. So that is called extrapolation. When the x value you're interested in is outside the data set. So representing this visually, here's the number line. We have data points for these values of x. So these are, let's say, the cricket chirps we have data for. 27 was in the middle of this data set. Data on its left, data on its right. 0 is completely outside that data set. Our data set runs between this and this, and 0 is outside of that. So 27, when we used x equals 27, that was interpolation. When we used x equals 0, that was extrapolation. And what we saw is that extrapolation is unreliable. We should be very cautious of any extrapolation we want to do. We might be able to get away with it if we're outside the data set, but really close to it. But here we were very far away from the data set, and the answer we got when we tried to do extrapolation was just completely wrong. This 30.281 doesn't mean anything.